Yes. Hello everyone. How are you all? I am Ashutosh and we are learning the structure of atoms chapter of class 9th, okay, through a lecture video series. Okay, and this is the 7th lecture of the series. Okay, and we already completed the basics of these different you can say structure model of atoms. Okay, and then we also have completed learning the electromagnetic theories, the various theories which are responsible for discovery of, or you can say development of quantum mechanical model of atom. Okay, in this uh, lecture we are going to learn very important concepts of atomic number. Okay, topics which we are going to cover in this lecture is our atomic number and mass number, and then valency, and then valence electrons. Okay, so like we already know, I already explained this, that atomic number means number of protons. Atomic number means number of protons. Like if I ask that what is the atomic number of carbon, so what we are going to do is to look for how many protons are present in the nucleus of carbon atom. Okay, so that's how the atomic number is, simply number of protons present in the nucleus of the atom. Okay, for it is represented by capital Z. For neutral atoms, we can say atomic number is equal to number of electrons also. Why? Because in neutral atom the number of protons will be equal to the number of electrons, and that's why either number of protons or number of electrons, okay, we can say that the atomic number of any atom. Okay, so like for sodium atom we can say that the atomic number is 11. Okay, why? Because it has 11 protons and 11 electrons both. Now for ions, now if we talk of Na positive ion, so it means that it has 11 protons but only 10 electrons or not. Okay, so for ions, we will call as the atomic number of any ion will be equal to its number of its protons. Not, okay, we are not going to say that the atomic number of any ion is equal to number of electrons. No, it is always equal to number of protons. So it means that for either it is an atom or an ion, we'll call it the atomic number of the species is equal to number of protons. Okay, clear? Now mass number. So mass number, we can say that the number of neutrons and number of protons, okay, collectively we call it as mass number. Why mass number? Because they are the particles which are responsible for whatever the mass the atom has. Okay, like most of the mass, because electrons are have very small mass, very little mass as compared to the mass of the neutrons and protons. We already discussed it. Like the mass of proton is like 2000 times heavier, 2000 times heavier as compared to electron, and that's why we are going to neglect the mass of electron when taking these neutrons and protons mass into our consideration. Okay, and that's why we can say that these are the particles, subatomic particles, which are responsible for whatever the mass the atom has. Okay, and that's why mass number is means the number of those particles which are responsible for mass of the atom, and that's why it will collectively, the number of neutrons and number of protons collectively we call as mass number of the atom. Okay, we also, since they reside inside the nucleus, and that's why they are called nucleons. Okay, so we can say that the mass number is equal to number of nucleons. Okay, it is represented by capital A. Okay, now let's see the representation. So if let's say we have this symbol of an element, and this Z is atomic number which is written, okay, at the like a subscript, and A is mass number which is written as superscript, like this. Okay, so like this it is a representation. Now if you want to find out the number of neutrons present in sodium, so we can call it like number of proton is equal to 11. See, it is given atomic number. Okay, and number of proton plus number of neutron is equal to 23, mass number it is given. Okay, so we can say 11 plus number of neutron is equal to 23. It means number of neutron is equal to 23 minus 11, it means 12. 12 neutrons sodium atom has. Clear? So I hope that this was sufficient to explain the term atomic number and atomic and mass numbers to you. Let's watch this video to understand it better.
When you look at the periodic table, you will see that each element has its own box. And within that box, you'll find two numbers: the atomic number, or proton number, and the mass number. But what do these numbers mean? The atomic number has a symbol Z. This number tells you how many protons are in one atom of an element. The number is always the same for all atoms of a particular element. Atoms of different elements have a different atomic number, meaning they have a different number of protons. For example, an atom of hydrogen has an atomic number of 1 because it has 1 proton. But an atom of oxygen has an atomic number of 8 because it has 8 protons. The next number we look at is the mass number. The mass number has a symbol A. The mass number tells you how many protons and neutrons are in one atom of an element. We need to remember that protons and neutrons each have a relative mass of 1, and that electrons are so small that their mass does not need to be considered in the mass number of an atom. So if we know the mass number of an element, and we know the atomic number, we can calculate the number of neutrons in an atom of a particular element. So the mass number equals the atomic number plus the number of neutrons. The atomic number is just the number of protons in an atom. Therefore, mass number equals protons plus neutrons. So if we take oxygen, oxygen has a mass number of 16 and has 8 protons. But how many neutrons does it have? Remember, mass number equals protons plus neutrons. We can rearrange this to show that neutrons equals mass number minus protons. Neutrons equals 16 minus 8 equals 8. Oxygen therefore has 8 neutrons. Let's take another example. Lithium has a mass number of 7 and has 3 protons. How many neutrons does it have? Mass number equals protons plus neutrons. We can rearrange this to show that neutrons equals mass number minus protons. Neutrons equals 7 minus 3 equals 4. Lithium therefore has 4 neutrons. So the atomic number is the number of protons in an atom, and the mass number is the number of protons and neutrons in an atom.
Okay, so this was the video. Okay, and with the help of this video we understand. Okay, we'll be, you can say we already understood this whole thing, like what is the atomic number and what is the mass number and all. Now the next thing which we are going to learn in today's class, in today's lecture, is concept of valency. Okay, what is this valency? Valency is, let's see, valency is actually the combining power of an element, combining capacity. Like valency only defines that what, how this atom is going to combine with other element, okay, with other atoms. And that's how it is very important. Why? Because the formula, okay, water will have this H2O formula. Okay, this all the water present in like anywhere in the universe, okay, will have this formula only, then only it will be called water. Okay, water cannot have this H3O or HO or HO2, okay, like this. No, no, then it will not called water. Water means, so it means that whenever oxygen combines with hydrogen to form water, okay, it will have two hydrogens combined with one atom of oxygen. Okay, so the combining capacity of oxygen is 2 and the combining capacity of hydrogen is 1 and 1. Okay, so we are going to learn these things in this valency. Okay, elements in the same group of periodic table have the same valency. Like same group means same vertical columns. So if we check this periodic table, okay, so we'll get that this hydrogen, then lithium, then sodium, then potassium, then rubidium, then cesium, all these are like in same vertical line or not, vertical column or not. Okay, so all these will have same valency, same valency. Similarly, we have beryllium, then magnesium, then calcium, then strontium, then barium. Okay, all these will also have 2. Okay, valency of 2. So same valency. Okay, same valency of 2. Okay, similarly, so these are the things. Now let's watch this video, okay, to get more understanding of this concept of valency.
To understand a few concepts related to atoms, let's begin with two simple elements, hydrogen and helium. Apart from the difference in the number of electrons and their structure, can you tell me another difference between these two? Yes, the most important difference lies in the fact that hydrogen is capable of reacting with several other elements, while helium never really does. Helium is a quiet, unreactive element that does not participate in reactions. But have you ever wondered why? What makes helium and many other elements also like neon, argon not participate in chemical reactions? And another question we would have is what makes other elements react spontaneously with each other? The answer is valency. Yes, one of the most important factors for reaction is the concept of valency. But before that, let's have a look at an important concept called the electronic configuration. Now, what could this be? As the name suggests, electronic refers to electrons, and the term configuration literally means arrangement or layout. That means the electronic configuration of an atom is the arrangement of its electrons in the shells. As simple as that. There are two facts that we need to recall. First, the innermost shell, or the first shell rather, has a maximum of 2 electrons that can be accommodated in it. Secondly, from the second shell onwards, whichever is the outermost shell, it can accommodate a maximum of 8 electrons. In simpler words, outermost orbital can contain 8 electrons at max. This state is called as the octet state. The term originates from the Greek word octa, which means 8. The octet state is considered to be a stable state. Let's understand this in a simple way. You love chocolates. Now, if there is a bag of chocolates kept open before you, how many will you try to grab at once? Needless to say, you will try and take as many chocolates as your hand can accommodate. That means the maximum number of chocolates is what anybody will wish for. Now, what have chocolates got to do with electronic configuration and valency? Let's understand the relation. As a part of human tendency, we will try and grab the maximum number of chocolates using our hands. Similarly, the atoms would want to have maximum number of electrons their shells can accommodate. That means if it's just one shell like in the case of hydrogen or helium, then the atoms would want to have 2 electrons in it. That will be the outermost shell of the atom. This will help them achieve a stable state. Similarly, for all the other atoms having more than one shell, it's obvious that they will wish to have 8 electrons in their outermost shell. And why is this so? That's correct. It's because the outermost orbital of any atom can accommodate a maximum of 8 electrons in it. That is the reason why all the atoms of various elements are in a constant struggle of attaining 8 electrons in their last shell. That is, achieving the octet state. However, it's not possible for all to have 8 electrons in the outermost shell. Imagine the case of oxygen. It has a total of 8 electrons. So can we just have one orbital around the nucleus containing all the 8 electrons? Absolutely not. In fact, according to the rule, we have to fill 2 electrons in the first and the remaining 6 electrons in the second shell, because the capacity of the first shell is to accommodate a maximum of 2 electrons. So can we say that the electronic configuration of oxygen is 2, 6? That's right. But now this indicates that oxygen does not have 8 electrons in the outermost shell. So how will it achieve its stable state? What can be done to have 8 electrons in the outermost orbital? Yes, oxygen can borrow or share electrons with atoms of other elements, right? Absolutely. This is how chemical reactions happen. Wait a second. Are we saying that chemical reactions occur because atoms of various elements give or take or share electrons between them? That's correct. And is this how compounds are formed? Absolutely. The giving or accepting or even sharing of electrons between the atoms of elements give rise to formation of chemical bonds. This ultimately gives us a compound. Now you tell me, how will the atoms decide how many electrons are to be given or accepted? How will they understand that electrons need to be shared with the other partner? Who decides all this? Well, the answer to all these questions is the concept of valency.
Okay, so the concept of valency, as you watch this video, okay, so now oxygen had 6, 2 and 6, okay, this type of electronic configuration. It means that it has 6 electrons in its outermost shell, okay, outermost orbit. So it means, and now it wants to have 8 electrons. All the elements are okay, they want 8 electrons in their outermost shell. Okay, so oxygen also wants 8 electrons to have, okay, so now it will take 2 electrons, okay, or what it can do is to lose these 6 electrons to have like fully filled outermost orbital. Why? Because now this, when it has lost all these 6 electrons, so then this inner orbit will become the outermost orbit or not, and it is full because it has 2 electrons. It can accommodate maximum 2 electrons, and it has 2 electrons. So either it can lose these 6 electrons to have a like complete full shell, okay, or it can take 2 electrons, okay. So which of these two options are like is going to energetically favored? Energetically favored means which is going to have or involve lesser energy. So this taking these 2 electrons, okay, will be a, you can say, will have a lesser energy involved as compared to losing 6 electrons, okay. So that's why the valency of oxygen is 2, okay. So by taking or sharing of these 2 electrons. Now similarly, if we take an example of this beryllium, it has 4 electrons. So the atomic number of beryllium is 4. So it means that it has as electronic configuration of 2 comma 2, okay. Now it can take 6 electrons, okay, to have 8 in its second orbit, the outermost orbit, or it can also lose these 2 electrons to have this inner orbit as you can say completely filled, fully filled outermost. So after losing these 2 electrons, now this will be the outermost orbit and it is fully filled, and that's why beryllium will also have a stable electronic configuration after losing these 2 electrons. And that's why, see, so it is taking, the oxygen was taking 2 electrons, and that's how its valency was 2, and beryllium is losing 2 electrons, and it also has a valency of 2. So after losing these 2 electrons, beryllium will form Be2 plus ion, okay, and after taking these 2 electrons, oxygen will form O2 minus ion, and these 2 ions are then you can say form an electrovalent compound, electrovalent bond with each other based on the charges, and that's how this BeO, beryllium oxide, is formed, okay. So we can say, by this discussion, we can say the valency of any element, any atom, is equal to either number of valence electrons, like in this case, in beryllium's case, number of valence electrons were 2, and that's why its valency is 2. Okay, so number of valence electrons. When number of valence electron is less than or equal to 4, so the number of valence electron was 2 only, so it is less than or equal to 4, so that's why the valency of beryllium is 2. Okay, number of valence electrons. Or 8 minus number of valence electrons, when number of valence electron is more than 4. So see, in oxygen's case, we had number of valence electron is equal to 6. Okay, so it means it is more than 4, and that's why the valency of this is 8 minus 6. Okay, so 8 minus number of valence electrons will get the valency of the element. Clear? So valence electrons means the electrons present in outermost shell or outermost energy level or outermost orbit. Okay, so this is all for today's lecture. Okay, we understood what are the atomic number, what are the mass numbers, what are the valence electrons, and what is the valency of any electron, any atom. Okay, so I hope you all liked it, enjoyed this video. Okay, if you have any query, you can post it on the forum, we are going to answer it. Okay, if you have not watched the previous lecture videos, please go and watch them all. Okay, so just to know the concept better, understand this all concept better. Okay, yeah, so this is all for today's lecture. So yeah, thank you everybody for your time. Thank you, keep learning from Ask IITians. Yeah, have a good day.